think we should start punctually, and we see that the TAC already started recording. So welcome to you all. Thank you to the participants for calling in, and also a big thanks to the speakers who very kindly agreed to make a presentation and join in the panel discussion. This is one of the online series which we call Minamata Online. We started this series in autumn, and we have 3 streams. The first stream is implementation of the convention, and the second stream is for the preparation for the conference of the parties that will be held next year. And the third stream is about Mercury science, and we co-organize this series with the ICMGP International Conference on Mercury as global pollutant. This session is about mercury emissions, estimation and projection. This is the third one in the science stream. First one was on trade, supply and demand of mercury. The second one was waste stream. And the background is that the Secretariat was requested to work on the effectiveness evaluation and try to put together a report on mercury trade, supply and demand, also covering the waste stream. And currently, Secretariat does not have official mandate to work on emissions and releases report, but scientifically speaking, emissions and releases is part of the global mercury flow. So as a scientific activity, we decided to look into this with the scientific community. So, and also we would like to cover the future projection issues. So this is a very brief statement of the background of this session. And do we have Ken already? Or I think Ken, are you here? Because I was going to turn to Ken Davis, my colleague in the UNEP Chemicals and Health branch.
Isaku, I'm afraid that we are still waiting for Ken.
Okay, then I think I will turn to him when he joins. So I will proceed to some housekeeping announcements. Firstly, to the participants, the participants are automatically muted, and if there is any need, we can unmute the participants, but we are not sure whether there's time for a oral question. So if you have questions to the panelists, please use the Q&A box, which you may find on the right-hand side of the screen, or I think you can activate it by clicking on participants chat and Q&A. So please use the Q&A box. You may put your questions already now, or while listening to the presentations. These questions are visible to the panelists if you address the questions to all panelists. So please make sure that you ask questions to all panelists rather than addressing it to a particular person. And also, this session is recorded. Presentations and recording will be posted on the website after the session. And then my housekeeping message to the speakers, as discussed, the presentations will be 8 minutes. So I think I will ring, make some noise like this at 7.5 minutes, and perhaps I will ring twice when you should stop. So this is a housekeeping announcement. Do we have Ken? Not yet. Then maybe I think we may invite him to speak when. Can I turn to?
All right, thank you very much, Isaku. It's great to be in a group of so prestigious and knowledgeable colleagues, panelists, and have the opportunity to present to you. My presentation is the presentation on the screen. I don't see this.
Tak, can you put? Or should I do that? I didn't. Okay, Tak, thank you.
There you go. That's my presentation, and in my presentation, I would like to outline contribution of science to the development of emission inventories, particularly global emission inventories for Mercury and global emission. Fourth question. Next slide, please. And on this slide, I would like to draw your attention to the fact that emissions to the atmosphere are very important, but already 3 decades ago, during first assessment, we made this with Jerome Driagu, professor, in fact, the indication that on a global scale, emissions to land and water are equally important, at least, than emissions to the atmosphere. And I'm glad to see that Dr. Wilson will also say probably a few words about the inclusion of these emissions to the current estimates assessments of global emission inventories, of global emission of mercury. Now, I'd like to also draw your attention to the fact that there is the emissions from anthropogenic sources are just on a part of emissions, global emissions, and probably 1/3 or so. So next slide, please. In addition to anthropogenic emissions, around 2,000 tons or so, we have maybe actually 5,000 of emissions from natural sources, but primarily from re-emission of deposited in mercury to terrestrial and aquatic environments. And then we sort of confirmed during the project GMOS global mercury of observation system, confirmed the estimates by Professor Celine that might be as much as 5,000 tons emitted in a year. And that's one thing, but the important thing is actually how inaccurate these data are. My goodness, if we want to talk about the reduction of emissions, we need to take into account not only emissions from anthropogenic sources, but also better, more accurate information from natural sources. Next slide, please. Among the anthropogenic sources, obviously Simon will do more on this issue, but I would like to draw attention to two sources, artisanal gold mining, which is growing source, and also we will have more information from Dr. Rico Euripidou on Africa, how much of this source, how important is this source in Africa. And the other one is in fact combustion fossil fuels. I mean, we are sort of the opinion that we are all set with emissions from co-combustion and so on, because I mean, we will introduce more renewable energy sources in the energy mix in various countries, not everywhere. And also, Rico will tell us about what are the plans for this source in Africa. Next, please. Gridded emissions, we have pretty interesting and detailed distribution of sources. With Simon and other colleagues, we did a distribution of emissions using the information of location of point sources, very, very useful information. But also there is still a lot of to be done in terms of distribution of so-called emissions from area sources, which is in fact central heating or re-emissions, so on. What are the surrogate parameters? Is that only population density that we have at the moment, or maybe temperature division that could be used to distribute the emissions from this of mercury from these sources? Next, please. Next slide, please. All right, in terms of emissions inventories, we have the inventories for some time, the projections for some time on the longer term time span, and but probably most often used at the moment are the projections that I did with the colleagues recently for the year 2035, using the information on current policies, new policies, which are also related to the Minamata, and also one scenario which is called the maximum feasible reduction scenarios. Next, please. Next slide, please. We have the potential to reduce emissions from around 2000 these days in from anthropogenic sources down to 1,100, which is like 45–50%, by adding new policies to the ones that we have today. If we, however, employ best available technologies everywhere in the world, and also best environmental practices, we could reduce these emissions by 80%, but that's theoretical, in fact. That's the MFR scenario. Next, please. And this emissions, the projections we also have already for modelers, so at least these scenarios for 2035 are available in this form. So I'm now that Professor Salini was using them to estimate, for example, the scenarios for the position of Mercury in this one. Next, please. Next slide. Summarizing, actually, we do expect in the future that we a decrease of emissions from anthropogenic sources, some of them at least, because we have developed the technologies and BAT for various most important sources, industrial sources for co-combustion as well. There is also an issue of improving combustion efficiency in the production of energy, and so on and so on. Now we have decrease of emissions, obviously, with the use of Mercury. Next, please. And then we may expect some possible increase of emissions from re-emission from aquatic and terrestrial surfaces due to the climate change impacts, temperature rise. Next slide, please. This is the last one that I have. For the future, what we need to do in the future, probably we need to still work on the improvement of emission factors, emission rates, and development of databases for sources, source categories which are not yet developed. Emission profiles, chemical speciation is very important. An issue that we work in the future. Methodologies for scenario estimates are also on the table. They will be improved in the future, and also the question of better technologies to reduce the emissions from various anthropogenic sources are on the place. Thank you very much for your attention. Thank you.
Thank you, Jozef. So since our colleague Ken Davis is here, I would propose that he speaks before we give the floor to Dr. Simon Wilson. Ken, can project his slide?
Hello all. I am very sorry for my joining late. I had a very ill-timed computer crash, but thank you very much, Esaku, for giving me this opportunity. I just want to take a couple minutes, first of all, to welcome all the participants on behalf of UNEP and the Chemicals and Health branch of UNEP, where I work. But mostly I just want to provide a little bit of information on the Global Mercury Assessment, in particular the latest 2018 Global Mercury Assessment, which will set the stage for Simon's deeper dive into this in just a moment. So you can see on the slide here, I'm showing the components of the latest 2018, the latest Mercury Assessment 2018. The Global Mercury Assessment is actually the fourth in the line of Global Mercury Assessments. The others, first one was published in 2002, after that 2008 and 2013, and now 2018. The last two or three, at least, have been in close collaboration with AMAP, the Arctic Monitoring and Assessment Program. And all of these global mercury assessments, from the first one to the current, to the 2018 one, were requested by the governing body of UNEP, the Governing Council, or what's now the UN Environment Assembly. And the basic mandate was to provide estimates on emissions and state of the science on mercury as a global pollutant. And so, of course, I would say the core part of the global mercury assessment, certainly the most relevant to this session here, are the emissions estimates, which are made on 17 sectors and done by country for a target year of 2015 in the case of the 2018 assessment. But in addition to the emissions estimates, the Global Mercury assessment contains summaries on other important aspects, state of the science summaries on advances in understanding of global mercury cycling, levels of mercury measured in air, atmospheric pathways, transport, and fate, releases of mercury to the aquatic environment from anthropogenic sources, mercury concentrations in biota, relationships between atmospheric mercury and trends in mercury levels in aquatic biota. And new in the 2018 assessment is a chapter on mercury levels and trends in human populations around the world. So the Global Mercury Assessment is actually several documents, which you see on the slide there. In the middle is the summary report, which contains the basic information with some nice graphics. There's also the technical background report, which is there on the left, and this is a fully referenced technical report which we publish jointly with AMAP, which goes into much more detail about the methodologies used, has data tables showing the background, showing the data. I believe now some of these are online. In the past, the technical background report contained all that in print. And then this year we've also published, this assessment, we've also published key findings, which are available in all of the all 6 UN languages. These key findings are part of what Simon's going to touch on in his talk next. So I have one more slide. You can go to the last one. Next slide. Thank you. So I just wanted to also introduce you to one tool that we now have to help analyze and visualize the emissions estimate data from the Global Mercury Assessment. This is an interactive map and dashboard that we've built on UNEP's MapX platform. You can find the link to this on our Global Mercury Assessment page, but I can also put a link in the chat so you can see this. And what it allows the user to do is to click on various countries and see the breakdown of mercury emissions estimates by sectors that you can see in that bar chart dashboard on the lower right. Now, the sectors have been aggregated somewhat from how they're originally presented in the assessment. For example, for non-ferrous metals, we've lumped those all together. We haven't broken out lead, copper, zinc, etc. But basically how this works is the map shows the overall mercury emissions. You can click on a country to see on the dashboard what the country breakdown is. You click on the ocean or non-country part to reset it. So I think this is a good way to learn more about the data in an interactive way and see some of the trends. So with that, I would like to finish, and again, I apologize for being late to this session. But now you'll be hearing much more about the Mercury assessment from Simon. And with that, I give up the floor. Thank you.
Thank you, Ken. So I'd like to turn to the next speaker, Dr. Simon Wilson, of the Deputy Executive Secretary of AMAP, who's going to talk about a bit more about the Global Mercury Assessment. Simon, you have the floor.
Thank you. And I'll wait for the slides to come up. And in the interest of time, just please move to the first main slide. So I'm not going to repeat much from Ken's, but this is just a slide to give a brief introduction to the part of the Global Mercury Assessment that I'm going to focus on in this talk, namely the the component of the work that was concerned with preparing a global anthropogenic emissions inventory for the year 2015. I'm also not going to present results so much. Those are available, I think, in the documentation that Ken referred to, but I'm going to try and bring out some messages that might be useful in a Minamata connection. So, yeah, it's already been mentioned. We produced, using a common methodology, an emission inventory for pretty much every country in the world looking at these 17 main sectors. Another thing I would like to highlight is that we involved a large number of experts, as large as we could, in this process. So there was a core group working on the science and the estimates calculations, but we had a large number of people. We had a couple of workshops, and we managed to involve people from a number of countries, actually from each of the UN regions, so in this works, which is very beneficial to the process. So if we could go to the next slide, please. The first main message that I'd like to bring out is that, as Jozef mentioned, emissions estimates are exactly that, they're estimates. And it doesn't matter what approach you use, a mass balance, a measurement-based approach, etc., or other various approaches that are used in national systems. All of these estimates involve assumptions, in some cases some major assumptions that reflect the knowledge that we have about various factors. They also involve a lot of information and data that underpins the calculations and underpins those emission estimates. And so consequently, all of those estimates that are presented anywhere are connected with, associated with large, sometimes large uncertainties. And what's sort of notable is that often those uncertainties are not quantified, but we tried in the GMA work to make those quantifications. So you'll also find that in the emissions reports. So the next slide, please. The second message I'd like to convey is that the key to the good estimates is good underlying information. In the GMA work, we because we were working at the global level, we relied a lot on some major international compilations of information, particularly sources like IEA and other global statistical compilations. We had input from some industry bodies, and we had some direct input from some industries, but I think there's a lot of potential there for having additional information. Yes, sorry, I just lost my place a bit. And all of that then relies on the state of knowledge that we have and how good that knowledge is. We also, as Jozef mentioned, recognize a number of things that we need to address more in this, especially things like the speciation and a number of sectors that we haven't yet addressed. But I think that's, I think the main thing here that I'd like to say is that we did also rely a lot on public domain information sources. So if that kind of brings us to the next slide, please. And that's the importance of transparency in this work. Right from the GMA 2013, when we prepared the 2010 emission inventory, a core element of this work has been to maintain the transparency of what we did. And in that sense, we put a lot of effort into documenting methodologies, documenting the sources of information, and the actual data that we used that went into the calculations, as well as providing example calculations. And we do this to provide a level of confidence and trust in the estimates that we come up with. And that's also something that's going to be important in any eventual Minamata reporting process or emissions calculations. It also, another piece of the work that we did was to compare the estimates that we produced with other estimates as far as they were available. We didn't find, of course, many global inventories, but we do have national inventories, and at the same time as we were doing the work was ongoing under the Minamata Convention to produce the MIAs. And I'd like to say here that I think comparing emissions estimates and asking questions about them should be considered a positive exercise. It's not a matter of saying this estimate is better than that estimate, but it provides an opportunity to explain, well, to look into differences, hopefully explain them. And where you can't explain them, it identifies needs for improved knowledge. And again, in order to do that, you need transparency of all the estimates that you're looking at. So this also provided some insights into the suitability of different reporting systems that exist at the moment for potential Minamata applications. A sub-message I'd like to convey is then a case for independent estimates to validate national reporting. if that's going to be part of the process. In that connection, also, I just mentioned that we did, looking at some of the preliminary MIA data, managed to identify some major discrepancies, which I think were resolved and certainly improved some of the MIA estimates as well. So the next slide, please. So the final message I'd like to bring out of this presentation is the challenges and the problems associated with temporal comparability. We, in the GMA 2018, we both produced the 2015 inventory and we also updated the estimates for 2010. And this is because we introduced some new sectors in the latest work, which were missing in the earlier work. So we had to introduce those to make data comparable, or the total inventory comparable. We also have introduced a lot of new knowledge that was compiled in the intervening period, so we could refine a lot of assumptions. So in connection with, I know that, for example, in the Stockholm Convention, there is the concept of an effectiveness evaluation process, and I guess that's going to be done in relation to Minamata as well. If emissions reporting is going to be part of that, there's going to be a need for consistency in application of methods and data over time, and also then, if necessary, a process to revise and update past estimates. And as Jozef mentioned, we use this data to prepare data sets that are used by modelers, for example, looking into source-receptor relationships. So it's not just the emissions themselves that we need to keep updated information for, it's also information on the geographical patterns and the locations. So if we move to the next slide, please. It's just to sum up the importance of recognizing uncertainties in the emissions estimates and the ways to ensure that the information continues to be available and transparent. The possible need in a Minamata context of, for example, an independent process for QA and validating reported numbers. And that's done in other conventions, for example, the UNFCCC, and LRTAP has a built-in process for that. I just mentioned already the problems of the temporal comparability. So the last message then, that was also raised, the extension and the potential that we have to extend this work to both land and water releases, and also look at recovery of contaminated waste that arise from controlling emissions. So that's, I think, the end, and thank you. And the last slide just contains the link to the resources that came out of the project.
Thank you, Simon, for the very informative talk. And I'd like to draw attention to the fact that we seem to have some questions in the Q&A box. So perhaps if the question are quite technical, perhaps you can type in your response rather than trying to respond to that already. Thank you, Simon. So then I'd like to turn to the third speaker, Professor Shuxiao Wang of Tsinghua University, to talk. Who is going to talk about the inventory in China? Shuxiao, the floor is yours.
Thank you, Isaku, for your nice introduction. So I will be very pleased to share some of the views on the projection of atmospheric mercury emissions in China. Next, please. Yes. So the mercury emissions in China there's not a national reporting system yet. They are actually calculated or projected by multiplying emission factors with activity levels. So to accurately calculate the mercury emissions, Tsinghua University have developed we call the technology-based emission factor method. So this method considers the influence of different factors on mercury emissions, including the mercury concentration in fuel raw materials, the mercury release rate of different combustion or production process, and the removal efficiencies of different air pollution control devices. So you see that both the mercury concentration in fuel or the mercury release rate are not expected to significantly change in future. So the future mercury emissions are mainly affected by activity levels and the ENDOPAP controls. Next, please. Yes. So the first policy affecting the mercury emissions is the climate policy. So you probably know that this September, our President Xi Jinping have pronounced that China aims to have CO2 emissions peak before 2030 and achieve the carbon neutrality before 2060. So with this climate goal, China will strive to achieve a long-term deep decarbonization oriented towards to 1.5 degree target. So according to the study of SEC SD of Tsinghua University, China will significantly reduce the coal consumption in near future, and the proportion of coal in the total energy consumption will be below 5% by the end of 2050. Next, please. So considering that renewable energy doesn't emit mercury to the environment, so the goal of carbon reduction, especially this carbon neutral before 2060, will significantly change the energy structure in China and also reduce the mercury emissions from energy sector. So the impacts from carbon policies actually are not limited to the Minamata Convention regulated sources such as coal-fired power plants or industrial boilers. It involves building sectors and all the other industrial sectors. So we can expect that about 95% of the mercury emissions from coal combustion will be reduced. So this accounts for about 45% of mercury emissions in China. Next, please. Of course, the policies on the mercury reduction, like the Article 4, Article 5, Article 9 of the Minamata Convention will also significantly affect the projection of activity levels. For example, by the end of this year, all the mercury added products will be phased out, and the mercury use per unit VCM production will be reduced by 50%. So this will reduce the mercury content in solid waste, not only from the production activities, but also from the use of mercury added products. So this will reduce the mercury input to those like cement plants co-processing the solid waste. Next, please. In addition, other policies which seems probably not related to mercury actually shall also be considered. For example, Chinese government have released this notice on the comprehensive implementation of domestic waste classification in all cities. So this means that all the mercury containing products will be recycled. So the mercury would not be released to the environment. So next, please. That's for the activity levels. So for the ENDOPAP controls, China also released a series of work plans. For example, for the coal-fired power plants, we will implement the ultra-low emission and energy-saving transformation for this sector. So this means by the end of this year, all the coal-fired power plants complete the ultra-low emission renovation. Almost all the coal-fired power plants will install high-efficiency SCR, wet FGD, low temperature ESP, or fabric filter to remove like traditional air pollutants, which also have significant co-benefits on mercury. So with the implementation of this policy, we will see that the mercury concentration in flue gas will be below 1 microgram per cubic meter. Next, please. For the waste incineration, all incinerators are required to install activated carbon injection system to remove dioxin. So our field tests have indicated that ACS also has co-benefit on mercury removal, although that the current mercury removal efficiency of activated carbon injection varies a lot, but the mercury removal efficiency can be significantly increased to up to over 90% by simply optimizing the ratio of carbon injection to the fly ash. Next, please. But there are also big challenges, for example, for the cement clinker production. So as you know, that under conventional operations, all of the mercury entering into the kaolin system through raw materials and fuels is eventually emitted out of the stack because the dust shuttling back to the raw materials. So therefore, the current traditional air pollution control devices has not high mercury removal efficiencies. So the best available techniques, such as the dust shuttling and collecting the dust instead of retaining it to the raw feed, or the solvent injection followed by back filter, shall be applied to reduce mercury emissions from this sector. Next, please. So yeah, I think that's the next slide. If you have any other questions, you can ask in the chat box, or you can send me email. Thank you very much.
Thank you, Shuxiao. Very interesting presentation linking to the Chinese national policy. And I would like to invite the next speaker, Dr. Rico Euripidou of the GroundWork, who has extensive experience in developing emission inventories in African countries. Rico, you have the floor.
Thank you very much, Asako, and good afternoon to all the participants on the webinar. I'd also like to acknowledge that I work with a group called the Zero Mercury Working Group, and Zero Mercury has been following mercury and working on mercury for about 20 years now. And we've been participating in all the processes that have led up to where we are now with the Minamata Convention. So a wealth of the knowledge comes from the collective and not just from the individual. Thank you very much. Next slide. In this presentation, I'd like to cover the following topics. I'd like to talk a little bit from a regional perspective. In the context of the African Minamata initial assessments, I've been working with Minamata initial assessments now for the last 5 or 6 years, and assisting African governments in trying to understand and make sense of the situation in their countries. And the kind of headline stories that come out of these African MIAs all point in the following direction: that mercury added products and their life cycle is very important in the region. That supply and trade is something that is beginning to be understood with the various trade reports that are coming out. We have a better picture of supply and trade, but the picture is a little bit more complex once mercury enters into the region. ASGM is a big driver for the demand for the supply of mercury. I'd like to talk a little bit about the rise for the use of coal as energy in Africa, and just give you a snapshot of an emerging picture, and a little bit about kind of regional coordination and cooperation along the way. I'll make some observations about that. Next slide, please. This slide, I think, is an important slide for everybody to realize how important mercury is to African governments. This is a snapshot out of the information tool that Ken described earlier, and it kind of shows a breakdown in which African countries they're doing MIAs. So where you see a shaded area on the map, these are all the African countries that are undertaking MIAs. And as you can see, just about the whole region has or is doing their MIA. Additionally, 35 of the 50-odd African countries have already ratified the convention. So that is a strong signal that Mercury in the region is an important issue. And I think we need to acknowledge that. And I think for the science and for scientists, we also need to recognize that that not enough is being done in the region to understand, you know, what's happening with mercury fluxes. Next slide, please. This is a snapshot from the most recent Africa Waste Management Outlook. It was done in partnership with UN Environment and a leading scientific institution in South Africa. And basically what it tells us, this report was a 2018 report, so it's quite recent. Waste management is a major challenge that faces the majority of African countries. Factors such as lack of awareness, weak environmental legislation and enforcement, limited resources, including financial, all result in very inefficient waste management in many African countries. And this has a huge potential to impact human health and the environment. And when we talk about mercury and mercury added products, we'll see how that picture emerges a little bit clearer. Open dumping is one of the predominant disposal methods used in Africa. And associated with open dumping is open burning of waste. So when we have the combination of open dumping and open burning of waste, then the impacts are not always going to be local, but can also be far-reaching. And again, mercury, black carbon, methane, open burning of waste, you know, these not only have local issues, but they have regional issues, they have climate change issues, and it's important, and we need to take note of that. And there's a debate about whether or not we have to try and understand how much mercury is released from open burning of mercury added products. But if we think about that problem a little bit more closely, it might become an obsolete question, and I'll touch on that a little bit later. The other thing we have to acknowledge is that Africa is a global destination for end-of-life electronic and electric waste. It's also a destination for second-hand vehicles that are exported from developed countries in all the other regions, from North America, from Europe, from Asia, and all of this accumulates as waste. There is an emerging market for recycling of things like lead-acid batteries and e-waste in formal workshops in Africa. So we see that emerging picture. And again, that also has huge potential to expose considerable numbers of people and also the environment. Next slide, please. This is a typical picture. And this is a direct quote from the African Waste Management Outlook. So 90% of waste disposed of at uncontrolled dump sites and landfills, and it's often associated with open burning. So of the African MIAs that I've reviewed, generally between 1/4 and 1/2 of emissions that are released into the environment are from the nexus of mercury added products and the associated disposal open burning of waste. And the take-home message in this respect is that we need to address mercury as an upstream problem. We need to enforce and find really good ways to help countries to meet their Annex A obligations in terms of the product phase outs, and to address mercury added products upstream. no mercury added products are coming into the region. The region is a net importer of mercury added products. There is very little manufacturing of mercury added products in the region. And if we address it as an upstream problem rather than a downstream problem of open burning of waste and the release of mercury into the environment and trying to formulate scientific measurements of that, I think it's a more efficient use of our time and our resources. Next slide, please. This is a snapshot from one of the trade reports that I mentioned earlier. In particular, it's the World Bank trade report. We can see the points of entry for huge amounts of mercury. We can see that there are hubs, there are major hubs in West Africa, in East Africa, and in Southern Africa. The take-home message for us is we can tally the amount of mercury coming in. It correlates with the demand for ASGM, but what we don't know is once it enters into a country, we don't know where that mercury travels. Most of the reports that try to find it out, they reach a bottleneck because the relationship between gold traders and the relationship between the manufacturer of gold and the supply and trade of mercury, that bottlenecks up all the information. So there's a huge demand for mercury. There's very little governance. The borders are porous and they're not very well policed. We do have trade bodies, but they are not able to coordinate and to cooperate to reduce mercury supply. So again, this is something that I'd like to leave to the discussion, but one way of addressing this is to make mercury obsolete. When I talk to my colleagues in Xero Mercury, those that are more expert on ASGM than I am, they say, let's make it obsolete. If the use for mercury becomes obsolete, we aren't faced with this massive problem of massive supply into the region. And then once it gets into the region, it just disappears. It disappears through, these disparate sites. Next slide, please.
Rico, can you try to wrap up?
Yeah, I'll wrap up now. So this just reaffirms the information in the previous slide. We know how much mercury is coming into the region from a supply point of view, but once it gets into the countries, it's very difficult to understand exactly how far it travels, how much of it is used, how to generalize that information between sites and within countries. And that's it. Thank you very much. That's all I wanted to say.
Thank you, Rico. And sorry for intervening. I was, in advance we saw his very interesting thread about calls. So it's a pity that you couldn't talk to it, but I think you can mention it when during the discussion session.
Yeah, we can go back to this issue during discussion. I mean the co-combustion.
Yeah.
Thank you.
Thank you. So now I'm going to turn to Toshima Sui, of the National Institute of Environmental Studies in Japan, who is an expert in the projection of emissions of greenhouse gas, which is quite related to mercury. So Toshi, the floor is yours.
Yes, thank you very much, Keisaku. I am very appreciate invite me for this very good opportunity. But I'm not familiar with the mercury issues. But I heard today's session, so I understand that many issues are overlap between the climate change issues and these mercury issues. So I hope our approach support or help your activities. So first of all, I'd like to introduce our own activities. So we developed our own integrated assessment model named AIA, Asia Pacific Integrated Model. So this model collaborates the many Asian countries on these figures. And so we started from the climate change issues, but we try to extend from the climate issue to the sustainable development issue. So maybe this Mercury issue is also one of the very good topics on the sustainable development. And next, please. Yeah, and we also estimate the future emissions of especially the greenhouse gas. And in order to estimate the future emissions, we utilize our own integrated assessment model because future is quite uncertain. And so we will give some scenarios like population, GDP, technology, and so on. And we estimate the future emission of the greenhouse gas emissions and also the impact of the climate change. Next, please. Yes, and this issue, the climate change issue, covers very, how to say, the very wide scientific knowledge. We need a very scientific knowledge. So but in order to combine with knowledge, we develop the model, and we provide our simulation result to the stakeholders like the policymakers. So the transparency and the data issue becomes also quite important to estimate and to discuss with the policymakers. Next, please. And in addition, yeah, so in order to estimate the future activities, the discussion with the stakeholders is also very important. Especially in Asian countries. So when we apply our approach to Asian countries, sometimes, yeah, so we collaborate with the researchers in Asian countries, and we try to keep the opportunity to discuss about our simulation result and their policies or actions. Next, please. In our approach, in order to estimate the future greenhouse gas emissions, we basically use three kinds of models. The one is EXSS, extended snapshot tool. This model shows that the snapshot of low carbon society visions, like at 2050. And the another next model is the AIM end-use model. This model focuses on the technologies. And by using this model, we can estimate the necessary technology to reduce the GHG emissions. And the last model is the AIM-CG model. This is the economic model. So in order to estimate the economic impact by introducing the countermeasures. So based on these three kinds of model, we provide, we develop the future scenarios and we discuss with the stakeholders. Next, please. Yeah, so I'd like to introduce the AIM end-use model, technology-based model among the three models. In the case of this model, first we provide the future energy service demand, which shows the right-hand side. And in order to meet this energy service demand, the least cost technology is selected. So then we can calculate the CO2 and other greenhouse gas emissions. Yes, next please. And this AIM end-use model covers not only CO2 but also other various greenhouse gas emissions and also the air pollutants. Unfortunately, at this moment, we don't cover the mercury, but yeah, so I hope that in the near future we try to improve the mercury issue. And yes, the greenhouse gas and air pollutants cover many sources, so that we can cover not only the gas type, but also the many sources, and then also we disaggregate the many regions like this. Next, please. And by using this model, we estimate the future emissions. So this slide shows the Asian emissions, SO2 and NOx, and carbon monoxide, and so on. And yeah, so we try to estimate the emission trajectories and to achieve the 2 degree target. And also we estimated some air quality by introducing the N.5 technology. Next, please. And region by region and gases by gases, we estimated the emission reduction potential by sector, by energy, and so on. So in this slide show the in order to achieve the 2 degree target, sector-wise, the emission reduction potential are estimated by gas. Next, please. And also, by using our system, we estimated some health damage due to the ozone pollution. So I think that Mercury also give a very severe health damage. So so this approach can be applied for the assessment of the Mercury. Next, please. Okay, so this is the final slide. So so many speakers had already mentioned about the importance of the future estimation. So by using the model, so we can experiment the future activity, especially to estimate the future emissions, and then we can assess what kind of technology and what kind of socioeconomic condition will be important. And so we can show the various pathways on the greenhouse gas and the other emissions. And based on our simulation result, we can discuss about the future scenario with the stakeholders. So we can, so we can discuss about the benefit of emission reduction trade-off, and also that sometimes the important point is that how to consider the non-market cost benefit. And I'm an expert on the climate change issue, so I'm also in charge of the IPCC AR6, and the AR6 covers the long-term global emissions to achieve the 1.5 target, and also the near-term and medium-term the national emission scenario using this kind of the model. So by combining the various types of models, we show the robust future emission trajectories and the future scenarios. Okay, that's all. Thank you very much for your attention. Thank you.
Thank you, Toshi. And from the Secretariat, I would like to let you know that we are working with the BRA Secretariat on the report diving into the relationship between chemicals management and climate change. So we look forward to the finalization of the report. Thank you, Toshi. And then I'd like to turn to the last speaker, Dr. Noel Celine of MIT. Noel, please.
Thanks. Thanks for the invitation to share some of the work that we're doing on mercury emissions, and in particular thinking about the future trajectories of mercury emissions and how they relate to impacts of mercury emissions over time. So I want to make a couple of different points, one echoing what several of the other speakers have said, and that is when you think about mercury emissions in the future, they're really coupled to the socioeconomic development and information that determines both mercury and greenhouse gas emissions, as well as other air pollutant emissions. So measures that are taken to reduce mercury interact with other measures, such as Paris Agreement commitments. And we've done some work to actually sort of quantify those synergies and overlaps, which I'll show. The other thing I want to underline is that when you think about looking at these mercury emissions projections, you ought to be thinking about them on a couple of different timescales. One is the very short term. You can think about the mercury emissions being associated with changes in responses to mercury deposition. But once you get to the medium and longer term, you have to take into account their impact on this re-emissions process. And when we talk about re-emissions and legacy emissions and mercury models, people often think about really long-term legacy past emissions. But what it's easy to forget is that what we're emitting today becomes tomorrow's legacy emissions. And in thinking about how to quantify the effect of emissions trajectories, you really need to take that into account. In the longer term, of course, because mercury emissions are also coupled with greenhouse gas emissions, even the climate impacts, potential resuspension of mercury, are coupled to emissions trajectories. And I'm not going to talk given time on this point, but it's important to note that there's also different response times in mercury species in the atmosphere and ocean. Next slide. So this slide makes the point about today's mercury emissions becoming tomorrow's legacy emissions. And really the implication of that is that, one way to figure out what happens to mercury deposition when you emit a different amount of mercury is to use an atmospheric model. So you can predict what changes in deposition would result. But because that today's mercury emissions are continuing, if you think about what would happen in 2035, for example, and you started emissions reductions now versus you started emissions reductions 5 years from now, you're not going to have the same impact in 2035, even if that 2035 level is the same. So, and that's because the emissions that happen between now and 2025 are tomorrow's re-emissions. So we actually quantified that effect. The effect of a 5-year delayed implementation of Professor Pacyna's new policy scenario. And we found that that could be up to 20%. And there's a spatial distribution of that in places where a lot of that deposition comes from that resuspended mercury, particularly in the polar regions. That is up to 20%. If in places where a lot of the deposition comes from very nearby sources, you have a lower impact. And we publish this in Environmental Science and Technology. Next slide, please. So you don't actually need to use a fully coupled atmosphere-ocean model to estimate this effect, but it's important to actually correct for it when you're thinking about the future impact of near-term emissions. So in this paper, I introduced basically a correction factor where you can say, okay, if you're emitting today, here's the long-term impact of those emissions. And you can say, okay, this mercury will continue to deposit over a time scale, which means that mercury will have that longer lasting effect. So taking into account that if you had constant mercury emissions, that legacy will grow. That legacy is not just growing because of the historical emissions, it's also growing because of the conversion of new mercury emissions to legacy emissions. And those are two separate things and really ought to be treated differently in thinking about emissions reductions, because one is something that happened in the past that we can't control, and another is something that's going to be happening in the future because of something we can control now. So separating out those two impacts when thinking about this legacy emission sources is important. Next slide. So this addresses some of the challenges that Dr. Masui was talking about, looking at applying integrated modeling to thinking about the overlap between greenhouse gas actions and actions under, for example, the Minamata Convention. And we did a pilot study for China to think about what kinds of mercury reductions you could get from Paris Agreement policies. And that would be this middle projection right here under the climate scenarios panel, and the Minamata Convention, and how those would add up. And we also looked at two other climate policies, slightly less and slightly more strict than China's Paris Agreement policies. And what we found was that, as Professor Wang said earlier, the there are synergies between those two policies. The Paris Agreement policies address sectors that the Minamata Convention does not. But you can't just add up those benefits because, again, thinking about the benefit you get from energy switching, from reducing, for example, coal, when that coal is cleaner, that benefit is reduced. So you really need to take that into account in the projections. And in order to figure out what the combined impact of policy is. Again, we did this for China, but these two kinds of policies are really occurring everywhere and should be taken into account when thinking about a holistic capturing of policies that can reduce mercury and greenhouse gas emissions over time. Next slide. And so I just wanted to end up by talking about some of the history of mercury. I have a new book together with Henrik Selin that looks at mercury in the context of the sustainability. So thinking about the sustainable development goals, you can think about these connections among different policies by thinking about the benefits from previous actions to reduce air pollution and continuing actions to reduce air pollution, but also the importance of addressing the different geographic impacts and the inequities, both in exposure and in the different capacity to act. And this is really illustrated by the impact of historical emissions and future historical emissions continuing being geographically dispersed. So one of the things we underscore is that choices about future emissions affect mercury in the context of broader sustainable development strategies. And I'll sum up by saying that I'm happy to provide any of the papers that I've referenced here. And if you have difficulty accessing them or the book, let me know. I'm at selin@mit.edu, and I'll put that in the chat. Thank you.
Hi, Joseph. You're muted. Joseph, unmute yourself.
I'm sorry. Okay. Is it okay now? Hello?
Yes. Yes. I was muted. Sorry.
Okay. Is it okay now?
Yes, it's okay. Yes.
Okay. Well, thank you very much, Ali, for your presentation. And I was asked by the Secretariat to do the little job of moderating the discussion that we have after the presentations. And I would like to probably start with it's an issue of emissions, current emissions. Emissions to the atmosphere are fine, and however, we are quite now aware of possible emissions of mercury to water, to the aquatic environments, and to terrestrial environments, and these emissions could be quite substantial. I've heard from Simon that Simon included at least the one for the water, which is probably direct releases of mercury to water from various sources. Could you, Simon, outline a little bit or discuss a little bit more to what extent you included emissions to water and possibly to terrestrial environments? Terrestrial, I mean, first of all, landfills, right? So could be actually fly ash, bottom ash, whatever. Could you, Simon, outline a little bit more, say a little bit more about this estimates, the first estimates?
Yes, certainly. So in the GMA methodology, which is very similar but not exactly the same as the methodology used in the MIAs, we're looking at inputs and outputs basically. So processes that mobilize mercury and bring them to into the environment, into society, and what happens to them. So we focused, as obviously, on the emissions to air. In a parallel activity, and this was for the first time in the GMA, a group were looking at releases to aquatic environments. And we employed something that's done in the MIA approach, which is sort of distribution. There's some factors for distributing emissions between different destinations, air, water, land. We, based on that, it's not as simple as it sounds, but once you've got emissions to air, you can effectively make some comparable emissions to other media. So we use that approach for some things. For some things, it doesn't work. I mean, if you can't work from emissions to air to water if there's no connection. For example, if there's a sector that's important for water that's not represented in the air emissions, that's no good. So we tried to take that into account. And in the case of ASGM in particular, there is a large potential release to water and land. We are not in a position at the moment to differentiate that, so we have a combined estimate. So yes, they are potentially substantial releases to land and to water. But as you mentioned also, this issue of contamination, as we adopt technology to remove emissions from air emissions by, for example, capturing emissions in scrubbers, putting it into the fly ash, for example, what happens to that fly ash becomes a big issue, because otherwise you're just moving the mercury problem from one place to another. So it's really important that we focus on that in the future.
Right. So just to make sure that we have an overall budget, in fact, of mercury, and portion will go to the atmosphere. I mean, there are obviously no major or accurate assessments to see what portion, in fact, of emissions of mercury will be going to the atmosphere, what portion. But then it might be as high as this emissions in the atmosphere could be comparable in terms of amount of mercury to water and then to the terrestrial environment. Another issue is a question about the sources. We sort of tend to believe that the major sources of mercury today are artisanal gold mining, which is obviously correct, and then we have a lot of information on the issue. However, there is also an issue of co-combustion, right? Still, and that was interesting to see on the presentation of Rico. I mean, it was not presented the last slide, but Rico, this is probably an opportunity now for you to say a little bit more about the co-combustion as an important source of mercury in Africa, because we say that in Europe and North America and Canada and so on, the US, and the emissions of mercury from coal will be reduced by various factors. Now, it doesn't look like in Africa. In Africa, it may be actually in increase. So, Rico, could you comment, please, on possible importance of mercury emissions from coal combustion in Africa?
Thank you. And Tech, if you can show that last slide, that would be great while I chat. So we've been tracking the coal expansion in Africa now for the last 5-6 years. Obviously, in South Africa, we have a very well-established coal sector. We have massive coal fields in South Africa, combust about 150 million tons of coal in our power stations, and we export approximately 60-70 million tons of coal. Those coal deposits are also found in Botswana, and they found in Mozambique, and they also found in some of the Eastern and Central African countries. What we are seeing here is a mapping of coal licenses for power plants or applications for coal power plants. And we were also very surprised to see how many there were and what the underlying driver for it is. So the Belt and Silk Road initiative by China, the investment initiative in Africa, is to a large extent driving this. This is where the finance is coming from. But the finance is also coming from many other big lending institutions in Japan, in the US, the US Export Bank, and also some of the global kind of agencies, the World Bank. So we need to pay attention to this. We need to pay attention to the expansion of coal in Africa. The surprising thing about this is that Africa has a huge potential for renewable energy. And even though energy demand is great in Africa, almost between 60 and 80% of the population don't have access to electricity. There is a great demand for it. And Africa has the opportunity to leapfrog. It can go straight from to a renewable kind of energy paradigm now that renewables are much cheaper than coal. So it's definitely something that we have to keep an eye on and keep paying attention to. Thank you.
Thank you for the comment. Is anyone who would like to add to the issue of combustion of coal and emissions? For example, in Asia, is that in China, we've heard from Shuxiao that there is obviously a policy to remove combustion of coal as a major source of electricity production or so. How about India and other places in the region? Is that actually the same trend as in China, that we will have the energy mix less in coal or fossil fuels? Anyone would like to comment on that? In Africa, we may expect the emissions on the rise, right, from co-combustion. How about in other continents? I think it's the issue of India. Is anyone would like to add?
I can add a comment, and that's that we've seen a big decrease in emissions associated with coal burning especially for energy, in North America and Europe. But as has been raised by several people, that shows the connections between mercury and other emissions. That was driven largely not by any efforts in particular to remove mercury emissions. It was driven by fuel switching to more economic sources of energy, more available sources of energy in those countries to make cleaner energy in those countries. The result, of course, has been that there's a lot of coal that's not being burnt in Europe, and if that's being moved elsewhere, then that's something that, as Rico says, that deserves a lot of attention, I think. Both from a mercury and the CO projection, yeah.
And CO2, yes. Now, another issue that is, in fact, related to, and is important in terms of emissions of mercury, is related to various chemical forms of emitted mercury, right? Because, I mean, various chemical forms would have the impact on the behavior of mercury after emissions. And I think we question to Shuxiao to comment, maybe we will have your comment on how various abatement measures, various techniques, in fact, would sort of affect the emission of various forms of mercury into the atmosphere and water.
Thank you, Joseph. So the mercury speciation actually will change when the flue gas passing through the air pollution control devices. For example, in the coal-fired power plants, the SCRs, which aims to remove the NOx in the flue gas, it promotes the mercury oxidization by about 30 to 80%. While the ESP and the fabric filter removes over 99% of particulate mercury, and the white FGDs will capture about 60 to 80% of oxidized mercury. So when the flue gas passing through all these air pollution control devices, generally the ratio of elemental mercury will increase, but the particulate mercury will be decreased to as low as 5% when it goes to the stack. And if there's wet flue gas desulfurization system, then the oxidized mercury will be also quite low in the flue gas. So when we are applying more and more air pollution control devices, you probably can see that the ratio, all the different species will be decreased, but the ratio of elemental mercury can be increased a little bit. But different devices actually have different impacts on this. For fabric filter actually removes not only particulate mercury, but also oxidized mercury. Yeah.
Mm-hmm. Okay, thank you very much. I mean, on the same issue, actually, I would like to ask Nelly, Professor Saline, I mean, how important, in fact, is the information on the chemical profiles, chemical species, in the modeling the transport of mercury and then deposition? Nelly, could you comment on that?
Sure. So I think it's very important to know what fraction is reactive and what fraction is as elemental mercury in order to figure out where the mercury is likely to initially deposit. And this affects assessments of where that impact on deposition could be measured. So, for example, if you're reducing mostly the reactive and particulate emissions, then you're going to see impacts on deposition regionally and locally, very near to sources. Whereas if you're reducing elemental mercury, then those reductions will be distributed globally. So we did a study several years ago looking at the kinds of control technologies that might be implemented under the BAT requirements of the Minamata Convention in both China and India in the power sector. And one of the things that we found was a lot of the initial kinds of end pipe technologies would actually also have substantial benefits domestically in these countries, as well as the global benefits of reducing mercury more broadly, particularly because of this effect where you see the reductions of reactive and particulate mercury. So it really shows that the benefits of mercury reductions are seen both locally and globally.
All right, so that will be important to continue working on speciation of mercury in emissions from various sources, obviously, and also speciation because of the equipment, implementation of various kinds of abatement. And then since we are with you, Nelly, I would like to ask you, and also possibly later on Toshi, on in terms of projections, do we have ways of, we work on ways of verification of our projections in the future. What kind of information or what kind of work we can do actually to see some of this verification issues? I mean, difficult, but then probably important.
So absolutely. And so there are a lot of different ways of verifying and checking the information in emission sources. The one that I work most closely with is I run a global atmospheric mercury model. So that will project concentrations of mercury that can be measured at different stations. And you can compare what the model would project based on the emissions inventory that we think it is. And then we can back calculate, for example, what that emissions must have been in order to match those observations. And again, you have to be really careful to take into account uncertainty, and we have mathematical ways of doing that. But the information in the spatial distribution of emissions, the distribution of meteorology, and the different sources can really give us a lot of information on what those sources might be. So we're actually doing a project right now to try to do this with the artisanal and small-scale gold mining source to try to get some better numbers on how much of that emission is going into the atmosphere relative to staying locally.
Okay, thank you. Very interesting. This is kind of a reverse modeling than implication of something. I would like to ask you, Toshi. I would like to ask Toshi, Dr. Masui,
yes,
about the issue of the possible impact of climate change on emissions of mercury in the future, particularly. In your model, you basically focus on climate gases, but also other pollutants, not that much on mercury, as you mentioned. But then could you comment, please, how is your feeling about the possible impact, how important this impact could be, particularly on the re-emission of mercury from terrestrial or particularly aquatic surfaces in the future when we change the temperature, when the temperature raise? Would you please comment on that issue?
Okay, thank you very much. Yeah, so the impact is quite important. And I think that yeah, maybe on this field, yeah, we need some typical or symbolic target or visions to reduce the Mercury. It's similar to the 1.5 degree target in the climate change issues. So the yeah, and the yeah, so we move forward. We move to the such kind of target. And then we will compare the impact of damage between such to achieve such kind of a target and the difference for the BAU case. So I think that many people yeah, don't know that such kind of importance of the market issues still. So in order to show such kind of the importance of the market issue, so the typical the target of vision might be needed. That's my point.
Okay. Thank you very much. I have one question to Aisaku. Aisaku, are you still with us?
Yes, of course. Yeah, yes, of course.
Unfortunately, I don't see on my screen questions, and certainly you have. Did you receive a question from the participants so we may address some of them? If you could see the questions.
Well, yes, but most of the questions have been already been addressed by myself and also Simon. But one question I think Simon didn't mention is one question about the decrease in emission into oceans from 358,000 tons in 2013 to 313 tons in 2018 report. I'm not sure whether where this figure comes from. So I'm not sure whether Simon or you may. I'm not sure which slide presentation he refers to. But do you have any idea?
Simon, are you comfortable with the question? Hello.
I'm not necessarily comfortable with the question, but it was on one of the slides you presented. But I would suspect that it is. And this is one of the points I raised up. It's between the initial estimate and the later estimate. There's just improved knowledge. People have revised their assumptions, and that therefore you have a number, and that sort of emphasises the importance of understanding and the transparency of how we get to these numbers, and whether we need to correct them over time if we make temporal comparisons. I'm not sure that's the answer, but it's certainly one of the possibilities. And
Oh, okay. Well, slowly but surely, we are getting into the end of our session. But before that, I would like to ask our dear panelists whether you guys have some questions after listening of the presentations and the discussion. Would you like to bring some either questions or issue for further clarification or maybe discussion? Anything like burning in your hands? Okay, Nelly.
Yes, I just wanted to comment on the uncertainty in the fluxes in the global biogeochemical cycle of mercury, and the difference from an uncertainty perspective of 350,000 and 310,000. These are not numbers that we know to the ton at all. So there's a lot of remaining uncertainty, particularly in the amount of re-emissions, legacy emissions, and releases that I would be careful of interpreting differences there.
Okay. Anything else? Any other issues to on this issue or this topic or maybe other topics from the panelists, please?
I'd like to raise just another issue around uncertainty, and that is many of the African countries that I worked with during their MIAs were, they were very cautious, and the uncertainty was quite scary for them. But what ultimately the way we got around this was that by triangulating as many sources of information as we could, and trying to reduce that uncertainty, eventually, once governments understood that the range was correct and they were range bound in terms of their estimates, they were a lot more open and a lot more happy to disclose that information. And this addresses some of the issues that Simon talked about in terms of transparency. In ASGM, uncertainty is a massive thing. If you think of Africa as a continent, imagine in a country like Ghana or Tanzania, where there are 1 million miners and there are over 100 sites. Imagine how difficult it is to scale the estimates from one site to another, where, you know, the practices are different, the ores are different. So there's always going to be uncertainty in calculating estimates in that particular sector. What we need to do is become comfortable with the uncertainty, and once that happens, then it's much more manageable and easier to act on and understand the data and understand what the data is saying to us.
Okay, thank you. Simon, did I see your intervention or?
Yeah.
Okay.
Yeah, I'm interested in the future developments and the relationship perhaps between the GMA and the Minamata arrangements, and I can also understand that in a convention context, uncertainty is undesirable. People like to, especially if there's a target for emissions reduction, then having widely having ranges doesn't help that. But I think there are sort of a number of things, and also this aspect of focusing on emissions to air and then generating effectively contaminated waste by reducing emissions to air that you have to do something else with. I think that's questions I'd like to hear more about, what the prospects are for under the Minamata Convention for looking at some of those aspects.
Thank you very much, Simon. Is there any other intervention before we sum up the session? I don't see any, and thank you very much again for the panelists to join the session. I think we may conclude saying that a lot has been done from the research side, from science, in fact, over the 3 or 4 decades already, to first of all have the first assessments of emission sources, emission amounts to the atmosphere, and provide the policymakers and this including obviously the Minamata. However, a lot has been done for the future, and this goes for research or science to improve the information on the completeness of sources, completeness of parameters having impact on emissions to the atmosphere, water, land, now and more important in the future for the projections. It's a lot of work that needs to be done in terms of improvement of accuracy of the estimates, and this is actually related probably to the accuracy of emission rates, emission factors, emission accuracy of statistical data, which are used in fact together with emission factors and so on. And a lot of work has been done on the technology to reduce emissions, but then technology is still in the major progress, and then we expect in the future probably more information, more technologies that would reduce emissions. Not only the question of reduce out of pipe emissions, but also in the process, like improvement of combustion efficiency if we're still going for a fossil fuel. So this is actually 36% today on average in the global, up to 50% in the future. So all in all, there's a lot of work for the scientists, for the research to do, including, for example, the process to study processes that bring the pollution to the atmosphere and the processes that bring the pollution not only from sources like anthropogenic sources, but also re-emission from terrestrial and aquatic environment. So a lot of work to be done and good perspectives. Good to have the conventions like Minamata, like OSPARCOM, HELCOM, AMAP in the first of all. And working with Americans, international cooperation is absolutely necessary. And so this is a lot of hope, a lot of positive feelings about the future collaboration and future expectations from science in order to improve the efficient implementation of the Minamata Convention targets. That's a kind of conclusion that I come from this session. I would like to thank you very much, and I'll go over to Isaku, the organizer.
Thank you, Jozef. And I don't have much to add, and I like just to add my sincere gratitude to all the panelists and the participants. Just one thing, we think that the follow-up is very important, and we learned the importance of interlinkage in the Mercury material flow assessment. We heard about the uncertainty ASGM, and it affects the estimate of mercury flow in the society and also the emission releases. So we also we heard from Simon about the linkage between media. So we will involve you or the panelists, experts in the some follow-up thinking about how we should understand the mercury flow and what that scientific knowledge tells the policymakers about how best to implement the Minamata Convention. So thank you very much. That's very helpful. Thank you very much, and thank you to all the participants.
Okay, thank you very much for having such a session organized. Thank you. Okay, goodbye.
Goodbye. Thank you.